When we look at the world around us, we can observe a very high level of detail in the appearance of the objects we see, such as the grain pattern on the wooden table or the colors and texture of the cloth on the sofa. If we included all of this detail when modeling 3D objects using computer graphics, the modeling and rendering of each object would be large, messy, and hard to process. What we can do instead is to model a comparatively simple object and then glue to it an image of its texture. Using textures, we can make objects look more appealing and realistic with relative ease. Sometimes textures are essential to an object. What's a Monopoly board without any detail? So you have a texture image in an object. The question then is how to place the texture on the object. This is called texture mapping, as coordinates of each pixel of the texture, often referred to as UV coordinates, are mapped to the XY coordinates of the object. That is, the mapping assigns each pixel on the object a pixel from the texture. Mapping a texture to a two-dimensional object or a flat surface is trivial. The two-dimensional texture coordinates are mapped to the two-dimensional object coordinates. In this mapping, the texture can be stretched or compressed to fit the surface to which it's being mapped. Another option is to use a one-to-many mapping to tile a smaller texture on a bigger object. Reza is using a simple brick texture to create the look of a brick wall by tiling the texture.
How'd the brick wall get here?
Hey, it's just a texture. I didn't even change the normals.
Unfortunately, it's not trivial to map a texture to a three-dimensional object, especially if it's a crazy object. There are many different textures and many different ways to apply a texture to a complex object. Often only one of these ways will lead to the desired effect. This makes it very hard for Reza to texture wood onto the world around him. It's okay, Reza, keep trying. There are a few relatively simple methods used to map textures to three-dimensional objects. We'll talk about a few of them. The easiest one is just to throw away one of the axes, for example the z-axis, and just treat the mapping as two-dimensional. This is called planar mapping. It's also possible to use 6 planes for the front, back, 2 sides, bottom, and top of an object. This is called box mapping. Another shape that can be used is a cylinder. With cylindrical mapping, the object coordinates are turned into r, theta, and height cylindrical coordinates, and then the theta and height are used to find the color in the two-dimensional texture. The cylinder used can be oriented on different axes, and this changes the appearance of the final texture. Another method is spherical mapping. This one turns the object coordinates into spherical coordinates. Then the latitude and longitude are used to figure out the color from the texture. The axes on which the poles of the sphere lie change the appearance of the final texture. We hope that gave you a good basic introduction to textures and the problems of texture mapping.